I'm now going to go try find Mike Walsh to do his presentation. I know he's at the back. Here he comes. Any questions for me, by the way? Good.
Good morning, everyone. I'm Mike Walsh. I'm a field applications engineer at Nvidia. I support our Quadro range of products and a little bit of work on GPU computing as well. And that's what I'm going to largely talk about this morning. Quadro family and GPU computing. Also got some neat demos outside, so drop by during the day if you'd like to look at those or talk more about Nvidia technology. I had a presentation that's probably worthy of 30 minutes, but I'll try to get through it in 10. So I might skip a few slides. So the Nvidia product range. Just wanted to run through that briefly. We have 4 sort of different business areas inside Nvidia. And just important to make you aware of one that you might not have heard of before, and that's in the bottom right-hand corner, Tegra. So you're probably all familiar with GeForce. That's the gaming products from Nvidia. That's really where Nvidia started building products that could delight and amaze gamers. On top of that, we developed the Quadro brand, which is the professional graphics brand, which has many advantages for professional users, not least quality, longevity of supply, support directly from Nvidia for problems and implementation and so on. Moving on then to Tesla. Tesla is our GPU computing range, so Nvidia recognized that we were developing what was in essence a very powerful parallel computer in the graphics device, and we enhanced that to allow for general purpose parallel processing or computing. And then Tegra, so hopefully one or two of you might have heard of the Tegra brand. Tegra is a single chip, system on a chip, graphics plus CPU system, around 7 processors basically implemented on a piece of silicon. Tegra is designed for mobile internet devices such as tablets, mobile phones. So the Motorola Zoom tablet that you might have seen adverts for, or you might see it in Carphone Warehouse, for example, that's based on Tegra. The Motorola Ultrix phone is based on Tegra. LG Optimus 2 phone is a Tegra phone. And there's lots of other tablets and phones that you'll see coming out during the year based on Tegra. And Tegra is a brand that you'll see more and more about in the future from Nvidia. So on the Quadro side, Nvidia isn't just about producing a graphics board. There's a whole ecosystem around that graphics board. I don't want to go through each of these items in detail, but just to say that we have on top of the graphics board some specialized hardware for different usage, 3D vision, for example, SLI for higher performance, G-Sync for connecting multiple machines together and synchronizing them, digital video pipeline for SDI work, quadruplex for high-end visualization, a whole range of software products. So more than half the engineers inside Nvidia are software people. So we have a massive investment in software. And a whole range of libraries and APIs that you can largely download for free. Most of these are enabling technologies that you can get hold of from Nvidia for free, so long as you're running them on a Quadro board. This is our latest GPU. This is called Fermi. Each of our GPU ranges has a code name. This is Fermi. Fermi is a device that contains 3 billion transistors. My background is the semiconductor industry, and even I'm staggered that Nvidia can put 3 billion transistors onto a chip. It's the biggest silicon device around in the world today. I won't go through each of the individual features, but all of our high-end graphics boards are now based on Fermi, and our compute boards as well. So the Fermi range, Quadro Fermi, our sort of buzzword, buzz phrase, exponentially better. So this was a definite step up in performance over our previous range of products. And we're looking here at three of the boards from the top end of the range. The Quadro 6000, for example, has a massive video RAM, VRAM, 6 gigs of VRAM to support massive data sets. A little bit more about the range there. I'm going to skip this slide. It's too much of an eye chart, I think. We even have mobile boards which contain our device. So this is an MXM style board that can be plugged into a mobile. So you can insert this into a mobile laptop, I guess heavy laptop, let's say, a big laptop, but to give you a workstation class performance from a laptop machine. And more, this is the format of the boards we're developing. Of course, a lot of cooling has to go on top of this in the platform that it's inserted into, that it's implemented in. We have some very high-end graphics devices that can support running a virtual Windows. So Windows thinks it has one big virtual screen, but in fact we're driving up to 8 screens, or more likely up to 8 projectors. So this is from our high-end graphics boards or our quadruplex graphics processors. The sort of thing that a quadruplex might be used for is scalable visual solutions. So things like multiple displays with multiple projectors, 4K panels or projectors. So bottom left-hand corner is a sort of graphic showing a 4K capable panel, 4K resolution in a single LCD panel. Power walls and caves are immersive techniques for rendering graphics in a very realistic format. And lastly, I just thought I'd slip this one in. This is a brand new technology that you may or may not be aware of. It's technology from Microsoft, but it leverages our graphics boards in a very unusual and different way. This is RemoteFX. It's available free in the latest service pack for Windows 7 and for Server 2008 Release 2. This allows you to virtualize the graphics board in a server and share it amongst multiple virtual machines on a server, driving across a network into multiple thin clients. So it's a very interesting solution. It's the first time we're really seeing a large graphics board going into a server and being shared amongst multiple virtual clients. It has some limitations. It only supports DirectX 9 and a very basic form of OpenGL. But it's the way things are moving, being able to virtualize the graphics card in the server. And 3D vision. If you want to see more about 3D vision, come to the stand. I've got some demos of 3D vision professional glasses. Tesla, GPU computing. Okay, so this is a completely different area for Nvidia. This is using the graphics processor to run code. The graphics processor is a very highly parallel machine, CPU if you like, or multiple CPUs, up to 512 CPUs making up the GPU. And this allows us to accelerate many algorithms, many parallel algorithms, in a way that hasn't been possible with CPU technology. So this is GPU computing. Just thought I'd throw in a picture of my new car here. In fact, not so. So why did I put this picture here? This is not a real car. This is an image that's been ray traced using GPU computing. One of the technologies that again is becoming real is the ability to ray trace graphics on the GPU in near real time. Not quite real time yet, that's the holy grail, but in near real time. So this was an image that was ray traced, and I've got some examples further on. GPU computing is all about putting the CPU along with the GPU. We can't do GPU computing on our own. We need the CPU. It's a heterogeneous solution, a mixture of CPU and GPU. And that allows us to create massively accelerated algorithms by running on the multiple processors in the GPU. The reason that's important is in multiple areas, but I took an architectural area here. So this is the sort of drawing that architects used to work with to perhaps show their clients how a new design would look. This is the sort of thing they can do today by simply ray tracing using GPU technology from Nvidia, using Nvidia GPUs, and using some technology from our partner company, Mental Images, which is the iRay product. Where else is GPU computing used? Well, I'm guessing that many of you might use Premiere Pro. Premiere Pro Mercury playback engine runs on the GPU, so it's using GPU processing to accelerate the playback of multiple layers of full HD video in the Mercury playback engine. This should be animated. It's not for some reason. I'm not sure that the codec is available on this machine. But this was intended to show a very jumpy, fuzzy picture captured from a drone of some sort of attack boat. We can use GPU technology here to stabilize that image, to see much more detail. And I can probably run this outside on my laptop if anybody would like to look at it in detail. So this is a commercial product from one of our partner companies that produces this. So they have a consumer version and also a professional version. GPU computing is now finding its way into the world's supercomputers. 3 of the top 5 supercomputers, the so-called top 500 supercomputers, 3 of the top 5 are using GPUs from Nvidia. So this is a 2.5 petaflop supercomputer in China. If you don't know what a petaflop is, does that mean 5 minutes or does that mean stop? Okay. For those of you who don't know what a petaflop is, come see me afterwards. I'll explain it. It's a lot of zeros. Here's some GPU computing that's used in the movie industry. So you've seen special effects in Harry Potter, for example, the fire effects at the end of one of the Harry Potter episodes. I'm not a great Harry Potter fan, so I haven't seen the movie myself. But some of the fire effects were rendered using GPU computing on NVIDIA GPUs. And this is some of the examples of what you can do with a GPU. This massively accelerates the task of rendering these highly complex but very realistic images. Okay, I hope there are some programmers in the room. I just thought I'd throw in a bit of programming here. I don't want to go through this in detail. I don't have time in 5 minutes. I want to show you how easy it is to get into GPU computing if you do write software. So the top box shows a conventional piece of code. The bottom box shows that code rewritten to run on the GPU. The green text are the only changes we had to make. This code is then automatically executed on the GPU. And the GPU is massively parallel, so up to 512 processors on one of the top-end boards. So we can accelerate that particular piece of code pretty massively when we run it on the GPU. And it's very, very quick and easy to change code to run on the GPU. It doesn't happen automatically. You have to rewrite your code, for sure. But it's, with the tools that we've provided, it's relatively easy to do that. Here's another example of GPU computing. This is a small company in Germany, Fluidyna, who've worked with some of the automotive companies to develop a computational fluid dynamics product. So this is taking the model of the car and calculating how the air flows over that car. And although I'm showing a video here, this is being rendered in pretty much real time. I think you'll agree that's fairly staggering, being able to calculate that more or less live. So the user can change parameters, can move the car around, can look at the airflow over different parts of the car, pretty much in real time. That's something that used to be done in wind tunnels. It can now be done pretty much live. Gosh, another eye chart. These are all the tools that we provide around GPU computing. There is a vast range of compilers, debuggers, third-party products that help you to write code for GPU computing. I'm not going to go into detail. Here's another car that I was thinking of buying. This is ray tracing again. So ray tracing was off. Now it's turned on. You can see the massive difference in the rendering here. So we're switching from sort of conventional textured rendering. Here it's going to go again. Okay, ray tracing turned on. So you can see the massive advantage for car stylers, for example, when they're working on what a car should look like, they can get photorealistic results from ray tracing, whereas conventional rendering has never achieved that. If you'd like to see ray tracing in operation, come out, look at the demos when you have a break. I have some ray tracing running there. GPU computing is used in a massive range of different areas: oil and gas exploration, drug discovery, financial, the moon landing. Would you believe that NASA lost their footage of the moon landings, the original moon landings? And we worked with NASA to use GPU computing to accelerate recovery of the moon landing material from all sorts of different sources. From cameras that were in the control room that were looking at controllers' TV displays and things like that, because they lost the original material. Pretty staggering, they can put a man on the moon and then lose the material. But so ray tracing and GPU computing used in lots and lots of different areas. Conventional ultrasound. Here's a picture of a conventional ultrasound view of a baby. Here's a picture with GPU enhancement. So we can use the GPU to process data from an ultrasound into a three-dimensional image of babies. This is a product from Siemens. It's already in use in the market. Takes a little while to get beyond this. If you want to learn about CUDA, GPU computing, there's a massive range of books, courses, lots and lots of free material on our website. Come and talk to me if you'd like to learn more about that. If you want to use GPU computing, we have worked very closely with a lot of the tier 1 vendors to embed our technology into a whole range of different hardware that's suitable for server rooms. Typically, these high-end GPU computing systems go into server rooms rather than onto your desktop, although the power of the graphics board and the power of CUDA and GPU compute can also fit into your workstation on your desktop, or even into your laptop, incidentally. So there's a lot of technology available from our partner companies, Dell, HP, Lenovo, Fujitsu, and so on, with our GPUs embedded into their hardware. Hopefully I hit 10 minutes more or less on the nail. Thank you. Any quick questions? Yep. Sorry, I couldn't hear you, and neither could the audience.
The support for Macintosh OS from Nvidia in the future, now that
yes.
Apple seem to have not doing it.
For GPU computing or for graphics?
For GPUs, for graphics cards in general.
We have one board that will work with the Mac. Only one board certified currently from our professional range. That's the Quadro 4000. That supports GPU computing. I've talked about CUDA as the mechanism to get into GPU computing. There is also another mechanism called OpenCL. That's a way of writing code that is suitable for compute in an open language, and that's developed by Apple, in fact. So
there's quite a lot of applications like DaVinci and Smoke, for example, which rely on CUDA on Mac OS, and it would be nice, for example, the boards which have SDI outputs from Nvidia to be able to be supported on Mac, for example.
Okay, yep, that's a good point. Okay, thanks. So I'll be outside all day. Please feel free to come by, have a chat, ask questions, whatever. Thanks a lot.